स्टडी करने जा रहे हैं वो है लीनियर सर्किट एनालिसिस, और साथ में उसके जो सब्जेक्ट है सिमिलर दैट विल इलेक्ट्रिक सर्किट एनालिसिस। बीटेक के कोर्सेज हैं ये, और ये तमाम कोर्सेज जो हैं, तमाम जो इसकी वर्किंग है, हम बहुत क्योंकि ऑनलाइन प्रोग्राम चल रहे हैं तो इसकी वजह से हमें इसको मल्टी सिम पे जो करवाना पड़ेगा। तो मल्टी सिम पे करवाने के लिए पहले आपको जो चीज़ें बतानी ज़रूरी हैं वो ये कि इंस्ट्रूमेंट कौन कौन से। तो सबसे पहला इंस्ट्रूमेंट जो है हमारे पास वो है ऑसिलोस्कोप है, डिजिटल मल्टीमीटर है, फंक्शन जनरेटर है, डीसी सप्लाई। ऑसिलोस्कोप जो है हमारे पास आखिरी फंक्शन होता है, यानी कि आपके पास जो सर्किट से करंट गुजरने के बाद जो डिस्प्ले आता है ऑसिलोस्कोप पे आता है। सही है, आखिरी चीज़ जो पहले लिख दी गई है। डिजिटल मल्टीमीटर, सही है, मल्टीमीटर है हमारे पास, डिजिटल जो वैल्यूज़ बताता है कि क्या कितना करंट है इसके अंदर क्या है। या फंक्शन जनरेटर हमारे पास क्या है, ये हमारे पास एसी सप्लाई को हम कह रहे होते हैं, फिर जनरेट करता है। डीसी पावर सप्लाई हमारे पास होती है, इसका मतलब कोई बैटरी है, इलेक्ट्रोमोटिव फोर्स है, ये तमाम चीज़ें। अच्छा, तो जनरल ऑपरेटिंग प्रोसीजर्स जो है हमें बताए गए हैं कि किस तरह से ऑसिलोस्कोप करता है क्या है। मैं आपको ऑलरेडी बता चुका हूँ ऑसिलोस्कोप का काम क्या है, इसके अंदर किस तरह से ये काम कर रहा होता है, और उसकी वर्किंग जो है बता दी जाती है इस तरह से। ये ऑसिलोस्कोप है हमारे पास, और इसके अंदर जो है आप डिफरेंट इसके फंक्शंस हैं, ये टाइम है, टाइम डिवीजन्स हैं, ये वोल्ट डिवीजन है, से उसके हिसाब से बताया जा रहा है कि किस तरह से आप देखना चाहते हैं। उसको पावर ऑन है ऑफ का बटन है हमारे पास, सही है। आप इसमें बता सकते हैं कि किस फॉर्म के अंदर चाहिए, एनालॉग में चाहिए, डिजिटल में चाहिए, किस में चाहिए, ये सब आप बता सकते हैं इसमें। अच्छा, इसका नाम है हैमिंग HM203 ऑसिलोस्कोप, ये यूके के स्कूल में पढ़ाया जा रहा होता है। अच्छा, उसके बाद जो है हमारे पास तमाम वर्किंग है, मैं इसके वीडियोज़ में ऑलरेडी इसको इम्बेड कर दूँगा, लगा दूँगा इसके अंदर, आप उसको देख सकते हैं। अच्छा हाँ, उसके बाद आपके पास यहाँ देखिए कि पुश बटन स्विचेस आउट हैं, अप है, सेंटर्ड है, कैलिब्रेटिंग पोजीशंस हैं, ये तमाम बटन से मौजूद हैं हमारे पास। वोल्ट है, डिवीजन्स हैं, स्विच ऑन रेड बटन, लेट एलिमिनेट अ फ्यू मूवमेंट शुड बी स्मॉल ब्राइट लाइट ट्रेस मूविंग फेयरली स्लो अक्रॉस द स्क्रीन। सही, तो पावर आप बता भी सकते हैं इसके अंदर, तमाम चीज़ें मैं अभी ऐड करता हूँ इसमें। वाई पोजिशंस क्या हैं, these are set as spot with rhythm is bright but not glaring and sharp focus as possible। ये आपके पास ये शार्प फोकस करने के लिए आपको बताया जाता है। ब्लर से आप खत्म कर देते हैं। टाइम डिविजन्स आ गई हमारे पास सेकंड के हिसाब से, परसिस्टेंस आ गई हमारे पास। अच्छा, ये हमारे ऑसिलोस्कोप इनपुट आ गई हमारे पास। इनपुट आने के लिए आप केबल्स हैं, BNC प्लग है हमारे पास, वो लगा सकते हैं। ऑसिलोस्कोप कैलिब्रेटर्स हैं हमारे पास, ब्लैक है और रेड है, आप बता भी सकते हैं इसमें। और वोल्टेज टाइम डिविजन्स हैं, या फिर डिजिटल आउटपुट आ रही है, एक पोजिशन वाई पोजिशन चेंज कर सकते हैं। सही, ये हमारे पास ये फर्स्ट लैब है, इसको आप काफ़ी ज़्यादा इंजॉय करेंगे, इसको आप करेंगे इसके अंदर, तो इसके मैं वीडियो भी लगा दूँगा इसके अंदर, तो आपको काफ़ी ज़्यादा मज़ा आएगा इसमें। ठीक है, तो ये आपको सिर्फ ब्राउज करके देखना है कि हाउ ऑसिलोस्कोप वर्क्स, किस तरह से काम करता है इसको, और उसकी वर्किंग क्या है। सिर्फ ये आपने जो है ये लैब 1 है आपकी, और आपने कुछ नहीं करना, तो ऑसिलोस्कोप का आपको रीड करना है, इसको बताना है, सही है। और तमाम चीज़ें तो मैं इसकी वीडियो भी पूरी डिटेल वाली वीडियो आपके साथ लगा देता हूँ, आपको स्टडी कर सकते हैं। ठीक है, तो उसके बाद जो है हम मल्टी सिम की वीडियोस में बताएंगे आपको मल्टी सिम पे काम कर सकते हैं, पहले कैसे करते हैं, फिर RC सर्किट्स पे आ जाएंगे आपके पास, तो काफ़ी आप इंजॉय करेंगे इस सब्जेक्ट में। ठीक है, ये काफ़ी डिटेल्स हैं इसके अंदर, ऑसिलोस्कोप की वीडियो आ रही है अभी, शॉर्ट सी वीडियो है, आप काफ़ी इंजॉय करेंगे इंशाल्लाह। ठीक है, अच्छा, ये क्वेश्चन है हमारे पास जो पूछे जाएंगे। कैलकुलेट द फ्रीक्वेंसी वेवफॉर्म 10 सेकंड, 5 मिलीसेकंड, 200 माइक्रोसेकंड, मतलब पीरियड वेवफॉर्म ऑफ फ्रीक्वेंसी 20 हर्ट्ज़, 150 हर्ट्ज़, सही है। किलो हर्ट्ज़ है हमारे पास 0.5 हर्ट्ज़, फाइंड द वैल्यू ऑफ पीरियड फ्रीक्वेंसी एम्पलीट्यूड भी। तमाम क्वेश्चन हैं जो कि अंदर पूछे जाएंगे, सही। तो हम आज तक के लिए इतना रखते हैं, और अब इसमें वीडियो ऐड करते हैं। ओके,
So in Lab 2, we're going to be learning how to use various pieces of equipment that we'll use throughout the rest of the semester. We have here our function generator, which generates output voltages that we'll use, and our digital oscilloscope that we'll use to record our data, make measurements of it. Start with the function generator. It's got a bunch of power on here. We can set the frequency, we can set the amplitude. We'll look at that in a second. It's got an output here. There's a special, basically it's just a cable. It's a BNC connector on one end, which plugs in here, and we hook these other two up to wherever we're going to measure. Up here, this is a sync out. We probably won't be using that during this semester. We'll just be using this output here. So that gets us our output. The digital oscilloscope has two signal inputs, an external trigger. We could actually hook these two together if we wanted to use the sync out with the external trigger. It has what are called scope probes. For the function generator, this is essentially just a wire. The scope probe, if you look at it, it has capacitance and resistance in it. It has electrical components in it. It's not just a wire. So when we plug it in here, and then we use these little clip here to measure things and the little alligator clip here. This should not be plugged into the function generator. The function generator cable should not be plugged into the scope. If you do that, who knows what you're measuring. Something else to pay attention to on the scope probes, you may be able to see them here. There's a little switch that says times 1 or times 10. You want them to be on times 1. And when we go into channel 1, it says voltage times 1 on the probe there. We want to make sure it says times 1. To measure these, when we hook things up, we want to make sure that all of the grounds are hooked together. So all these little black things should somehow be hooked together in your circuit. And we can put the scope probe across there to measure things. And then we see some signal on the scope there. So let's move in a little more closely and look at a lot of the functions of this. So as we said before, we're going to be playing with equipment in this lab. We start with the function generator here. I've got the output hooked up in the output. It's on high Z. That's important. You can read about it in the lab. If it's not on high Z, it could be on the 50 ohm setting. You can see 50 ohms there. You don't want that. You'll be off by a factor of 2 in your measurements. So make sure that you have it on high Z. It's right now, we can measure its frequency, so it's set up for 1 kilohertz right now. I can set it to be 5 kilohertz or 18 kilohertz or whatever. Let me go back to 1 kilohertz. The amplitude, this is 5 volts peak to peak. I can go, say, 2 volts RMS, 8 volts peak to peak. I can set the various amplitudes there. There's also an offset, which adds a DC level to it. We're going to make sure that's set to 0 here. And there are different types of function outputs. I've got a sine wave right now, and we can see the sine wave over here on the scope. I can go to a square wave. You can see the square wave, the triangle wave, sawtooth, and it'll put out noise if you want, which isn't too useful to us. So that's the function generator. So right now it's set out to have a 5 volt peak to peak, 1 kilohertz signal, and let's go over to the oscilloscope and see what we have here. Assuming I didn't know where it was, I can press this auto set button and that will locate the trace for me. So that comes and finds it here. I can adjust the vertical scale here to make it fill more or less of the screen. I can adjust the time scale here to spread it out or to make it tighter together. And I can move it up and down with this knob here. You'll also notice there's a small arrow there on the side. That's the trigger. I'm going to go to the trigger menu. It is triggering on source channel 1 here, and I can adjust the level of that arrow, and that basically tells the scope where to take a snapshot. So that may be something you want to do. The scope also has measurement functions, so I can go into measure, and it's got little functions here. So at channel 1 frequency, I can go and it's channel 1 type frequency. Let me change it to peak voltage. And then I can go, so now it's measuring the peak to peak voltage. This one is set up to measure the mean. That one's set up to measure something on channel 2. There are a bunch of different measurement functions I can do. I can also bring up cursors. So I've got cursors, so that's the type amplitude. So that's up, down. Put it on to source channel 1, and now you see my cursor there. There's the upper cursor. I'm going to adjust it to some height there. I'm going to go to the lower cursor, and I'm going to bring it there, and it now tells me the difference between those. I can also go back and measure time type cursors, so now they're left and right. So now I go to the first one, I can say put it at the peak of that wave there, go to the second one, put it at the peak, the next peak, and it measures the time difference between those two. A lot of things to play with on this scope. One last thing we're going to look at is we can actually record data to a memory stick. So I'm going to plug a memory stick in there. It's going to take a second to recognize it. There, it's got it. And now I am going to press the Save Recall button. There are a bunch of different things I can do. This is save waveform to a file. I need to make sure it's doing channel 1. And it's writing it to this particular file. That's a .csv file, which is something Excel can read. You may also want to recall things, save all. You may want to save an image of this. This will save it as a JPEG. You can save the setup of the scope, and you can save various things, and here's the Excel file. So that's useful to do. We'll be using that more in another lab, but it's useful to be able to save things onto a scope and then look at them on your computer. So essentially this lab is just playing with this equipment. There's a lot of things to do. You want to play with it a lot. So this lab has been learning how to use the function generator and the digital oscilloscope, two pieces of equipment they're going to use for the rest of the semester. Hopefully you played with this, you've become familiar with it, you've learned a lot of the functionality of this, and we did a so-called frequency response measurement of the R2R ladder that we did in Lab 1. Frequency response measurement, as we will see, is one of the basic measurements we'll make this semester. It's measuring the output voltage versus the input voltage across a wide range of frequencies, and also the phase difference between the input and output voltage across a wide range of frequencies. And we'll do that with the measurement functions on this scope. The main thing of this lab is just to play with this equipment, learn how to use it so you're familiar with it. And when you start doing things in the next lab where we're measuring things,
Dear viewers, welcome to the very first demonstration of the first apparatus being used in an electronic circuit. Starting with the various names of the parameters, I like to say this is the function generator, this is the CRO, that is a cathode ray oscilloscope, this is one more function generator, this is a dual power supply, this is a multimeter, and on which we generally mount all the components is known as the breadboard. Let us first concentrate in one of the most important apparatus of electronics, that is known as the CRO, that is the cathode ray oscilloscope. Let us look into it in detail. This CRO is known as the cathode ray oscilloscope, in which a CRT screen is being used. In this, we have two channels, channel 1, channel 2. Why these two channels are there? In channel 1, you can give one input, in the channel 2, you can give the other input. And in this screen, you can compare both the inputs. Let us go into more detail what this channel 1 do and what this channel 2 do. If you can look into it, see there are various buttons over here, and one is known as the input over here written. So this where we use a PNC both side cable, which is known as a CRO cable. We use this connector over here in connecting this input. Now when it is connected in the input, whatever is coming in this side will be shown on the screen. So let us begin with the other things like what is ground, what is AC, DC, what is this invert, what is this Y pose. Let me give you an example using this function generator so that the different buttons used in this CRO can be clear to you. I am using this function generator. Here it is written something called output. So from this output means this function generator, whatever it is generating, will be output from this button and will be coming through this wire into the CRO. So let us connect it over here. Now explaining you both the function generator as well as CRO together. How a signal is being generated using a function generator and how a signal is being viewed using a CRO. Let us on it. This is CRO I have on. This is the function generator I have on. Now initially it will initialize its settings, then it will come to the normal state. Now you can see that it is in the normal state. Now, as I say, the function generator generates a signal. What kind of signal it generates? There are various signals that a function generator can generate. It may be a sinusoidal wave, it may be a triangular wave, it may be a square wave, it may be a pulse, it may be a ramp. So let us take an example of generating a sinusoidal wave of 10 kilohertz. So how can we set this function generator to generate a sinusoidal wave of 10 kilohertz and the amplitude of suppose 2 volt? So first you go to this button called frequency. When I press this frequency, you are getting this is FREQ, which denotes frequency, and it's saying that right now this frequency that is generated by this function generator is 26 kilohertz. By using this knob, you can vary the generated frequency. So I am making it suppose a frequency of 30 kilohertz. And next there is one more button called amplitude. Now you can see it's AMPL denoting amplitude, and you can see it's right now generating an amplitude of 10 volt. Using the same knob, you can vary the amplitude. See, it's varying. So suppose we are using an amplitude of 2 volts. So right now I am generating a sinusoidal wave. It's a SIN called sinusoidal. Frequency is 30 kilohertz and amplitude is 2.004. So whatever is being generated here, let's see whether that is being received here or not. Some of the other things I like to explain together with the function generator is that there is a call function, this button. When you change this function, you watch this SIN. When I am pressing it, now this is TRI. That means you are generating a triangular wave. Next I am pressing SQR. That means you are generating a square wave. Next when I press this, it says RMP. Means you are generating a ramp signal. If I press again, it's saying RMP with minus sign. That says that you are generating a minus ramp signal. Again when I press it, it says PLS, that called pulse. As here there is sign is no sign, that means a positive pulse. When I press it again, there is a negative, that means it is a negative pulse. When I press it again, it is called DC. DC means direct current signal. It is a negative DC signal being generated by this function generator, which amplitude is 5 volt. Now we all know that DC don't have frequency, so that's why when it is DC there is no option of frequency. Again when I press it, we are coming normal to the screen where all the parameters are shown. That frequency is this much, it is a sinusoidal wave of amplitude 2 volt. So 3 buttons are most important. One is to set the frequency, one to set the amplitude, the third to choose the function you are going to generate, and this to vary the different amplitudes or the frequency. So let us see whether this has been generated over here or not. When you want to see this signal over here, and suppose you have connected this wire to the channel 1, you have to first select that this button. It says that this is triggering 1/2, or in the upper part it says CH1/2. That means CH denotes channel, whether you are in channel 1 or channel 2. When you don't press it, when it is in the upper part, it says that you are in the channel 1. So this screen will be generating things or be viewing things which is put in this channel 1. When I press this, this says that now this screen will be showing what you have put over here. So now right now I have connected this to channel 1, so I will make this mode to channel 1. Now I have to search the signal, because whatever is generated, this has to be seen over here. Now I have to search the signal in this screen. First of all, I will use this button called ground, called GD. When I press this ground, you have seen there comes a reference line. We have to set this line using this Y pose. Y pose means Y position. Y position changes the position of this line in the Y direction. It's this way. When I am moving, it's changing the position. So when I press this ground, I have to set this line in this black line you have seen. It is a little dense line. I have to set this over here. After setting this over here, I have to release this ground. Now I have given an amplitude of 2 volt, but I am not able to see my signal. So I have to set this knob and this knob. This is the magnification of the amplitude and this is the magnification of the frequency. As my magnification may be too large, that's why this signal is not coming on the screen. So what I have to do, I have to minimize my magnification. So I am minimizing it. So I am getting something. So as I have kept this, connect this output to the input of this CRO. Now I have to search my signal. There coming some signal, but it's not clear. I have put here what? A sinusoid. So this signal also should look like a sinusoid, but it's not looking like. So either the frequency is too high or the frequency is too low. In that case, it's moving over here. So let us change its time period. If I changing this time period and try to get the signal, we are getting the signal. But we are applying a sinusoidal. What we are getting? A sinusoidal. Here, this part from this y-axis is known as the amplitude of the signal, and this x-axis is known as the time period in which the signal is repeating its cycle. Using this time period, we can determine the frequency of a sinusoidal wave. All of us know that. So, as you can see, this signal is moving. So, here we have that one feature of this CRO that you can make this signal hold. It's called the hold off. Using this hold off, what I am doing, I am making this signal stop so that we can calculate the time period. So, this is what, as I said, is the magnification of the amplitude. So this button doesn't changes the magnitude of the signal, but it just changes the view. It's same here, 2 volt is coming, here also is 2 volt, but I am changing the view. It's a magnifying glass kind of thing. Okay. So as I have changed the view, let it be somewhere here. I am taking this as my proper view and making this signal a stable using hold off. I am going to calculate different parameters of this signal. 2 parameters are most important. One is the amplitude, the other is the frequency. How to calculate the frequency using this CRO? You can see that this whole screen of this CRO is divided into various blocks. And each block is again divided into various small blocks. So this is called one block. If I show it using a pen, this entire is one block. And one block is divided into 1, 2, 3, 4, 5 small blocks. So in 5 small blocks means each block is 0.2, 0.4, 0.6, 0.8 and 1. So each block is 0.2 small block and the entire is 1. So the one entire block is divided into 5 small units of 0.2. So now calculate this amplitude. The most easiest feature in this CRO is this XY. What this XY do? When we press it, it simply compresses the x-axis. Because when we say amplitude, we are not concerned about this x-axis, we are concerned about the y-axis. So I press this x-axis, this xy, so it compresses the x-axis. We are concerned about only y-axis. So now let us count this, how many blocks this line is taking. Okay, if you feel like this is not countable, using this y-post, adjust it properly. Suppose this, make this black line as the reference line and just set it at this line and then start counting from there. So if I count from here, if I set it properly, if I count from here, you can see that it is one entire block, then it is again going up till how much? It's near about 1.9. So from 1.2, 1.4, 1.6, 1.8, it's around 1.9. So if I calculate this amplitude, I will show you how to calculate the amplitude. If I say amplitude A, this amplitude A is equal to what? Is equal to the number of blocks. That was. Now we are going to calculate the amplitude. So how to calculate the amplitude? As I already told you to press this XY, where this will be compressed, and now we are going to count the number of blocks. After counting the number of blocks, we found that this is 1.9. So this amplitude will be equal to 1.9, that is the number of blocks, into, why this 1? This is 1 because here this knob is at 1. So the magnification you are using is 1. So I have made 1.9 into 1, which is equal to what? 1.9 volts. So why this volt is there? Because here you can see from this bigger gap till this bigger gap, you have different magnification units with a value of volts. See, V is written. So this V is denoting volts. From this bigger gap to this bigger gap, in the right hand side you can see this is MV, called millivolts. That's why whenever this knob is in this range, you have to use the unit volts. When this knob is from here to here, somewhere in between, you have to use the unit millivolts. So in total, we are getting the amplitude to be 1.9 into 1, which is the magnification, is equal to 1.9, the unit is volts. So you have the amplitude of 1.9 volts, but we were giving how much amplitude? 2 volts. So this 2 volts is coming down over here 1.9 volt. Why the difference is there? You might have heard about different resistance losses. So this wire has some resistance. You are using a big wire, so this wire has various resistance. So what happened? Whatever is been generated, due to the resistance of this wire, some part has been dropped here. So exactly 2 volt is not coming, a small error that has been dropped here, and 1.9 volt is coming. So this is how we calculate the amplitude. Now moving to the next parameter, I am releasing this x1. We are moving into how to calculate the frequency. To calculate the frequency, we should know the time period. So first, again it's moving, so let it be first ground. Take it at the center, release the ground. Then make it hold if it is moving. Now to calculate the frequency, we should know the time period. Because we define frequency as the number of cycles completed, or the time taken by one cycle to complete its complete rotation. So let us discuss that what is happening here. It is always calculated in x-axis, the time. So here, if you can see, if I say one cycle, if I make it a little more stable. This is one cycle. If I say from here to here, it is one cycle. Or from here to again coming here is one cycle. So whichever way you can take, whenever the signal repeats itself again, that is said to be one cycle. From here, if it coming till here means again from here it is repeating it again. So it's called one complete cycle. From here to here, from here to here, wherever you can take, you have to take one complete cycle. So you have to calculate here how many blocks this one cycle is taking to complete its repetition. So let us calculate this. If I make it a little more stable, from here it is taking around, if I calculate from here, it's taking around 1.3 as the number of blocks taken by one cycle. Now the next parameter we are going to calculate is the frequency. How to calculate the frequency? To calculate the frequency, we have to first calculate the time period. What is time period? The time period is the time taken by one complete cycle to complete. Here if you say one complete cycle, that is this one complete cycle, or any one which is a one complete cycle. So to complete that one cycle, what is the time taken? We have to take into blocks. If you know the blocks, we can, using this magnification, we can calculate the time taken by that particular cycle to complete its rotation. So if I see what is the time taken by this cycle, you can put here. So this is one complete cycle, it is almost taking 1.7. If you count this scale, if I count this scale from here, if you take that this is one cycle, from this to this is around 1.2, 0.4, 0.6, 1, it's 1.7. So it is 1.7, you can say. Time period is 1.7, and you have to see the magnification of this time period. Now, right now you can see this is the knob. This knob is at 2. So we are using this into 2. So this 1.7 into 2 is giving us 3.4. Why I have taken milliseconds? Because from this gap you can see, from here till this gap, there is a small line. The unit will be in seconds if this knob is somewhere here. From here till this gap over up, the unit will be millisecond if the knob is in this range. From this gap till this gap, if the knob is over here, then the unit will be microsecond. So we have 3 different units in this scale: seconds, milliseconds and microseconds. So as my knob here was in millisecond range, so I have used a unit millisecond. Now we all know the relation between frequency and time period. Frequency is the inverse of time period. So to calculate the frequency, I am making it 1 by time period. What was our time period? 3.4 milliseconds. In 3.4 I have multiplied it into 10 to the power minus 3 because all of us know that milli is 10 to the power minus 3. So the millisecond is now converted into second. When I divide this all, I am getting 294.21 Hertz. And what our first frequency being used was 300 Hertz. So we are very near to the frequency which is generated. Again I am saying why the difference is there, because of this wire being used. I am saying again and again that every wire you are using in an electronic circuit or in electronic apparatus has some resistance. Due to that resistance, the resistance may be offered to the frequency, may be offered to the voltage, may be offered to the current. Due to that, if it is 2 volt, we were getting less than 2 volt, that was 1.9, and as it is 300 Hertz in the frequency, we are getting less than 300 Hertz, but it is approximately equal to the same. So this is how we calculate the amplitude and the frequency using a CRO. The same thing can be if I change this from here and I put it over here. Now I am not getting the signal because my channel is in 1. I have to change this channel. Now my channel went to channel 2. So now whatever is giving in this input will be shown on the screen. So as the view is small, that's why this is used to magnify the view. So you can see the signal properly. Same way you can change the frequency and you can vary the amplitude. So you have 2 channels. The amplitude view for 2 channels are different, but the frequency view is the common for both the channel. Okay. So this is channel 2, now it is shown here, and this is channel 1 if you are giving this input here. If you want to see both the channel input, then you have to, suppose I am using one more function. Now this I have added one more function generator. I have connected it to the channel 1 and the another function generator I am connected to the channel 2. You can see over here that using this, when it is in channel 1, you are viewing the signal which is generated from here and we are viewing here. When we make it channel 2, this signal is being generated by this. When we want to see both, then you have to do this 12. You can see one signal, there are 2 signals, one is generated by this and the other being generated by this. So you can view both the signal using this 2-channel CRO. Okay? And the frequency is same. See, if I change this frequency view, the frequency of both the signal are changing. Even this signal frequency changes and the signal which is behind the first one is also changing. But if I change this magnitude of channel 1, you will observe that only one signal amplitude is varying because this is independent of the channel 2. When I vary this channel frequency amplitude, you can see the amplitude of this signal is varying, but the behind that signal is not varying because this is independent of this. So both are functioning independently when it comes to amplitude, but both are functioning at the same time when it comes to frequency. So this is about 12. So there are 2 modes, one is channel 1, channel 2, and we can also see both the using. Few things that I like to explain, I won't be showing it on the CRO, but what are the things? One thing, what is this? It's called intensity, which increases and decreases the intensity of the signal. There is another called focus, which increases the focusness. See, it's becoming little blurred and not very clear, so you can increase, if I say that signal. If I change this, see, it will become a little blurred. I want to change the clarity, so the focus is changed. Here is called X magnitude. See, saying X magnitude into 10. When I press it, what you are seeing, that my amplitude or the, you can say the view of my time period is been multiplied by 10. So it is 10 times more, means my one cycle needs 10 times more number of blocks to complete its rotation. This is what into 10 means, but I make it to the previous stage. Here is some calibrated 0.2 volt and 2 volt. This is showing the symbol of a square wave. So this means that when you connect one wire from here and you want to view, means this CRO can also generate a square wave of 0.2 volt amplitude and a 2 volt amplitude. Both are there. So this small feature is been inbuilt in this CRO. This is not of much importance. The same can also be used using function generator, but you are using this for the CRO. This is a component tester. It's not very important for this level because when we insert a component over here, by using this component figure, we'll get one figure over here, one view. That view will say whether your component is working or not. So that's why it is a component tester, depending on the figure. Generally, we call those figures as Lissajous figure. You might have heard the name of the Lissajous figure. So what is the pattern of the figure? Determining that pattern, we say whether the component is working or not. Okay. I already explained you about this y, movement of y. Right now this y, and this is x is a movement of its x direction. This is xy to calculate the amplitude by removing it, and this is for frequency, this is for amplitude. For now, this is all about CRO and how a function generator works. So I like to mention one more point about the function generator that I forgot to mention previously, but that is not like any Q kind of thing. If you know now also, you can relate. So what I want to mention is, let's see, right now in channel 2. So whatever is coming in this channel will be viewed here. I forgot to show you the practical use of this function. So when I change this function, triangular, right? What is it getting? A triangular wave. Again I change this function, square. What I am getting? A square wave. The square wave, only the upper and the lower limit is shown. The line connecting the upper and lower limit is not been shown in this CRO, the upper and the lower. So it represents a square wave. Again, when I change the function, it is a ramp. You know, this is called a ramp signal. This is in first that direction. Your tiltness is on the right hand side. When I change the function again, it's a negative ramp. You can see previously it was on the right hand side, the tiltness. Now your tiltness is on the left hand side. So it's a negative ramp. Next, when I change the function again, a pulse. So it is giving a small pulse. This is one pulse, second pulse, third pulse, small pulse. And again I change the function, it's giving a negative pulse. Before these pulses were on the positive side, now the pulses are on the negative side. When I again change the function, you are getting a DC. Now to see this DC, as this signal is coming on this channel 2, I have to change this mode. Here's the AC and DC. When it is up, it is AC. When I press it, it is in DC. So you can see how many volt? DC minus 5 volt. Now I should get what? From here, as I am making the mode, this is DC 5.0 volts. This is the amplitude magnification, I have increased it. From this reference you have to calculate. So from this reference if you calculate, this is 1, then 0.2, 0.4, 1.5. 1.5 into how much? 0.2. It is saying 0.35. So you can calculate the function DC. So we all know that DC don't have frequency, though it is a straight line. And as the other signal like this is having frequency, so it is not a straight line. So when DC comes, it's a straight line. When DC doesn't come, it is a sinusoidal or any signal having frequency. So by changing this function, we are getting different signals over here. So this is how the function is being viewed here, and you can use different channels or the CRO to view whatever this function generator is generating and what this is viewing. So at the end, in the conclusion, I can say that this is a source, this is the eye of an electronic engineer. Eye means where we view things. So this is viewing all the signals being generated by this source on the eye of the CRO. Thank you for watching this.